In this video session, we are going to see a problem on real numbers for the 10th standard CBSE Mathematics on the topic real numbers. Find the least number which, when divided by 6, 9, 15, and 18, leaves a remainder of 5 in each case. How do we solve this problem? We have to find the LCM. And how do we find the LCM? By prime factorization method. So let us see the thinking process. To solve this, we are looking for the least number that leaves the remainder of 5, which is given the problem that its remainder is 5 in each case. So when divided by 6, 9, 15, and 18, to find this number, we must find the LCM of these 4 numbers. Then add the remainder 5 to the LCM. This will be the required number. So let us go to the solution. Let the number be n. This means that if we subtract 5 from n, the result must be divisible by 6, 9, 15, and 18. So let us define this. N minus 5 is equal to L, where L is the LCM. So we can write this the other way also. N is equal to L plus 5, because we need only n here. L is the LCM of these 4 numbers, and L must be divisible by 6, 9, 15, and 18. That is, L is equal to LCM of 6, 9, 15, and 18. Thus, n is the required number which leaves the remainder 5 in each case when divided by 6, 9, 15, and 18. Now let's proceed to find the LCM of these 4 numbers, 6, 9, 15, and 18. By the prime factorization method, let us factor each number separately. 6 is equal to 2 into 3 primes. 9 is equal to 3 into 3, which is written as 3 squared. 15 is equal to 3 into 5. And 18 is equal to 2 into 9, or 2 into 3 into 3, 2 into 3 squared. This is how we factorize each of these numbers in as primes. That is called the prime factorization. Now take the highest of all highest powers. The powers you see here, it is the highest power of, we see common factors 2. So 2, the highest power is 1. So 2 power 1. Okay. 3 is also a common factor. So the highest power is 2. So 3 squared. 5 has no common factor. It is not a common factor, but it has to be taken into account. Because since we are finding the LCM, we have to multiply that also. So exactly, we got 2 power 1 into 3 squared into 5. This is how we do it. So LCM is equal to 2 into this 32 into 5 is equal to 90. Sorry, it's not 32. Okay. 3 squared. It should be 3 squared over here. Sorry, there's a mistake there. 3 squared. Because we got it as 3 squared. No, it's not 32. It's 3 squared. So 3 squared. So we find the LCM as 90 and we subtract this 90. If we add 5 to this, the remainder is 5, isn't it? So this is exactly divisible. See, LCM is exactly divisible by these numbers. But we want a number which is giving a remainder 5. So let us add 5 to this number to get 95. And that's the good answer. That's the required answer for this particular problem. Now let us verify this. To verify this, we have the verification process. The verification consists that just 95, you have to divide each number. So 95 divided by 6 first. Obviously, it is 15. The quotient is 15. The remainder is 5. 95 divided by 9. Obviously, it is 10 there. Quotient is 10. And the remainder is 5. 95 divided by 15 gives 6 as the quotient. And the remainder is again 5. 95 divided by 18 gives 5 as the quotient. And the remainder is also 5. So we get the remainder 5 in each of these cases. Therefore, we verified that 95 is the least number that satisfies all the conditions, that it leaves a remainder 5 in each of these cases, isn't it? Okay, that's it. That's the solution.